Alright, in this video we're going to talk a little bit more about iterators. We've been talking about generators and iterators as a way to sort of calculate a next value in a sequence, so that way you don't have to generate the entire sequence and take up all the memory required for that whole sequence. So generally speaking, an iterator is used when you only need one value at a time in a sequence instead of the entire sequence. Right? So it's a method of saving memory. So we've been talking a lot about the iterators, and what we're going to do now is talk about iterators with respect to class construction. Okay, so this is going to tie into some of those functions we've used, the global next function, the iter function, that sort of thing. So we're going to talk about how those functions relate to a class as you're producing the class yourself. Okay, so I have the beginning of a class here, PrimeProducer, and this is going to be a class that allows us to produce and iterate through the prime numbers, and it's going to automatically generate primes as they are needed, and we can specify, which number of prime we want. And if we don't have that one, we're going to calculate until we get that one. So there's going to be this list of primes that our class uses and has access to, and as we calculate the primes that we need, we're going to store that list, right, so we can reference it later, right? And so that will allow us to not have to calculate it so many times, and then we'll only use the amount of memory that we need, and we won't have to produce or waste CPU cycles as we're calculating new values. So here we go. Class PrimeProducer. This is the way that you construct a basic class, and then the name of the class, note a capital letter P, and then we have the colon, and here is just a variable. This is a class variable. So this variable should always be referenced by the class name itself. Okay, so if I go down here, print PrimeProducer dot primes. Okay, this is what we mean by accessing a class variable. You use the class name itself and then dot primes. Now what we have here is standard syntax for running a program. So a lot of times if you have a class you're defining, you're going to import that with another program. So I can use this PrimeProducer class in other programs. But if I want to actually test this out, a lot of times you might see something like this for smaller projects where you check to see if the _name variable is main. If that's the case, that means we're running this file directly and it's not being imported. So then it's safe to run the tests. Because if somebody's importing this, we don't want all the tests to run, because that's going to slow down their program, right? But if I run this directly, that means I'm going to run the tests on this program. All right, so let's get to it. PrimeProducers.primes, right? So we're going to run tests for this file, and we're going to print this out. This is a class variable. So again, since this is going to be importable, we're going to capitalize the letters because there's a class in here of the same name. Running tests for PrimeProducer.py, and this is our current list of primes. So we're just going to start out with those two values. All right. So now one of the things we might want to do is what does it look like when we create one of these things? So I'm going to have a PrimeProducer object, and we can print that out. All right, and so this is sort of the default way Python prints out any kind of object as a string. So when I print this out, what does that mean? Well, it depends on the object, right? So each object can actually define what it means to be converted into a string and print it out. There are a couple of different ways to do that. You can define something. These are called Dunders. They start with double underscore. Dunders are usually specially named variables or functions in Python. We see a couple of Dunders here, right? These are a global Dunder. But generally, when you see a Dunder, that means it's Python specific, something Python knows about or put in itself. So you probably don't want to name your variables double underscore, because you might be overriding something built into Python. So in this case, there is the Dunder str, which is going to allow us to sort of decide what string is returned whenever someone calls the str function on our object, our class, right? So this is a instance method. So instance methods always have to include the self parameter first, and we want to return the string value that we want to be returned when we convert this object, whatever it is, into a string. Well, we can look at this. We take a look at what they did. We can do something similar, right? We can say, let's make this a format string. Let's go back up here, format string, and we'll say we want to get the type of this object. So we'll say this is a self, and then we will say at, and then we want to get the hexadecimal memory location. So ID of self. Oops. Let's use our format string notation, curly brackets. The ID of self will give us the memory location, and let's turn that into a hexadecimal string. Right? Let's see, is that how they did it? It's pretty close. So let's see what ours looks like now. Let's save this file and we'll run it. So we have class PrimeProducer, right? And then we have the extra angle brackets. So we might not need these extra angle brackets. All right, something like that. We could we'll get rid of those. All right, so we changed it, but that's basically what Python does by default. It sort of defines this string dunder as something like this. It's close to this, right? That's the idea, because every object is going to have a memory location, and then you can talk about what it means to be that object, right? So this is defined in the main scope, and it's dot PrimeProducer. That's the type of object it is, right? All right, so that's what happens when we print something. If it's not a string, Python automatically calls the str function on it. Now notice, the dunder value str is associated with a global of the same name. So you're going to see that a lot with these dunder values. One of which is going to be the dunder next. That's going to be synonymous with the next global function, and then the dunder length. We can go ahead and add the dunder length here, and then we're also going to talk about the dunder iter, because that relates to the iterables. But here, what we can do is, what is the length of our object? Well, it depends on the object, but in this case, we're going to reference our class variable, so PrimeProducer dot primes, and we want to get the length of that list, right? And that's what we want to return. So we're going to return the length of this list. So now I could change my string to say something like at hexadecimal value, and then I could say with length of self primes. Right, so I can print out that, and I can also just print out the length of my PrimeProducer instance either way. Okay, so there's currently 2 primes in that list, and if I just do length of that, we see that there's just 2 items in it. All right, so that's all well and fine. So those are dunders, and like I said, we're going to use the next dunder and the iter dunder, so we can go ahead and define those now. We'll leave them blank. There we go, next, and we'll just pass on that, and then we'll define the iter dunder, and we'll pass on that as well. Okay, so the first thing we want to do is when we create one of these instances, this class variable is shared between instances. So I can have as many different instances of PrimeProducer as I want. They're all going to share this primes list. And when you think about it, if you're using an application that's going to need a lot of primes, that's what you want to do, because once a prime is calculated, there's a certain amount of cost to that, either CPU time and also memory. And so if it's already been calculated, we don't want to waste that CPU again, right? So if you have different PrimeProducer instances, they're all going to share that same list of primes, so we're not going to duplicate those lists in memory, and we're not going to have to duplicate that the processing power that it took to calculate those primes. Okay, so what we're going to do here first is we need to think of a way to generate the next prime, right? And so we're just going to use a very simple way to do that, not very advanced, just sort of the first thing that comes to mind here. So let's think of how we can generate our let's say next prime. And this is an instance method, so we'll add the self parameter. And so what we want to do is we want to have some sort of test prime number. And that test prime number, we're going to start with the last prime value we have. So that's PrimeProducer.primes. So again, this is the class variable primes, and we want to access the last item in the list. Okay, and to get the next prime, we simply say while true, and we say test prime plus equals 2. All right, so the reason we started out with these two variables is because 2 is prime, but it's the only even prime number. Every other prime number is odd, so we can always go back to the last prime and then add 2 to it to test to see if that number is prime. Now again, this is a very naive way of calculating primes, but it's pretty easy to follow for all audiences. So what we want to do is we want to see if this thing is prime. So is it prime? We're going to start out and say it's true, and then we're going to prove it wrong. And if we're unable to prove it wrong, then this will still be true. So how do we prove it wrong? Well, we need to iterate through all of our primes, and if any of these prime numbers divides evenly into our test prime, then we know it's not prime. Okay, so we have to iterate through all of our primes. So for p in primes, and it's not just primes, this is primes on PrimeProducer dot primes, right? So that's what we're iterating over, and we need to test to see if this prime number p divides evenly into our test prime, right? So if test prime modulus p, so modulus is going to give us the remainder after division. If anything that divides evenly is going to have a modulus of 0. So test prime divided by p, if the remainder is 0, then we say is prime, and we set that equal to false, right? And then we just break out of that loop. Okay, so eventually we're going to have a long list of these prime numbers. As soon as one of them divides into our test prime, we don't have to keep trying all the other primes. We already know it's not prime. So we can just, that's what this break statement is doing. It's saying break out of this loop, right? We don't need to keep iterating through all those primes and dividing to see if this is prime, right? Because we already found one prime, or one of our prime numbers divides evenly, so that means it's definitely not prime, and we'll break out of the loop. Okay, so if we break out of the loop, that means we're in this outer loop here, the while loop, and we'll go back and we'll add 2 more to our test prime. So it's still an odd number, and we set is prime back to true, and we try again. And so we keep doing this process. Okay, at some point, we're going to get through this entire list of primes, and is prime will have never been converted to false, because we will never have a prime that divided evenly. So at this point, if we get through this entire list of primes, and is prime is still true, right? So if is prime, then that means we add that test prime to our list of primes. Let's see. Test prime. Okay, and if it is prime, then we've successfully generated the next prime. So we can break out of this loop. Right? And then we can return test prime. Right? So we don't really need, there's a number of ways to do this. We could just return test prime here. Then we wouldn't need the break statement. If you return in the middle of a loop from a function, it automatically breaks you out of the loop, right? So that's one way we could do this. We could say if it is prime, we could break out of the loop and then unindent this, right? These would be roughly equivalent. So there's lots of ways to code things, right? So let's try this. Let's see if our next prime function works. All right, so let's say next prime. I'll do a couple of those and then we'll print. And we should see how many items are in our prime list. So we have 4 prime numbers. All right, so that works. We can at least, let's make it by default. It's gonna immediately calculate some prime numbers for us. All right, so as soon as we instantiate one of these items, we're gonna use the initializer function. So this is basically the Python equivalent of a constructor. This is called whenever you instantiate one of these classes. So whenever you call this instantiation, when we call PrimeProducer, Python creates an object, and then that new object is passed into this init function as the self parameter. All right, and what we can say here is we can do something like, for I in range, and we could pass in some number of primes it should calculate to start out with. So we might start with like 100 primes to start with. And so what we want to do is we want to call self.nextPrime. Okay, so this is going to run 100 times, so that will give us 102 primes. And that's not what we want. We want 100 primes. So for I in range num minus the length of PrimeProducer.primes. Okay, so that's going to be 100 minus the 2 we already have, so we should calculate 100 primes. All right, so let's run that and see if that works. Okay, we've got 100 primes. Now we might want to see, the first couple of primes and then the last couple of primes to make sure, this is the case. So to do that, we can change our string dunder with however many primes, and we can say primes equals, and we're going to kind of generate something here. Let's say P equals PrimeProducer dot primes, and we can say P0 comma P1, there we go, and this is P2, and then we'll say comma dot 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 comma, and this is -2 and -1. Okay, so as long as we have 3 primes, this should be okay. So we might start out with 2, 3, and 5, and because we made this calculation based on this list, we should still be fine. So we're always going to have at least these 3 primes, and if our default number is 100, then we're good. Got my computer keeps popping out of video record mode. All right. So we've got our string, and we are printing out the primes in the list. So let's see what we get. So 2, 3, and 5 are the first 3 primes, and then the 99th prime and the 100th prime. Okay, so that seems sort of reasonable. What's next? So we're generating the primes when we first instantiate this thing. Now we want probably some function to get the nth prime, right? So we've got next prime here. Let's define a function that says get nth prime. Okay, and we'll pass in n. Okay, so what we want to do is basically we want an if statement. You know, if this prime is already in our list, right? So if n is greater than the length of our primes list, oops, capital there. So if it's greater than that, we have to iterate in a while loop, right, to generate primes. So really, instead of an if statement, we could just say, you know, while n is less than the length of our primes, right? If I want the 100th prime, then the length of our list has to be at least 100, right? So as long as n is greater than our list of primes, we need to generate another prime, right? And this get nth prime is a instance method, so we have to, you know, always remember to add that self parameter first, right? So in instance methods, you always have the self parameter. That self parameter is the object itself that you're talking about, so the instance of the object. And so what we want to say is self dot next prime. So this will give us the next prime, and it'll keep generating primes until we have enough primes to access the nth prime. Once we have enough, this will be false. We'll break out of the loop, right? And so then we can return PrimeProducer primes. So this guy here. And we don't want n, right? Because if I want the first prime number, that's index 0. So n minus 1. So whatever value I put in here, n, is going to be 1 or more. And so the index for that value is always going to be 1 less, right? So that makes sense. This should get us the final prime. Now, if n is already less than or equal to the length of my primes, we don't do any calculations. We just return it. So this is an example of caching values. So we have a cache of all these values that are stored, and if we've already calculated it, we just grab that one. We don't have to do any calculations. All right, and it looks like my indentation's off. So here's the indentation there. Let's get that right. There we go. Everything's lined up now. Get nth prime. All right, so let's see what we can do to get nth prime. All right, so we got the prime numbers. We got our PrimeProducer. All right, let's say n equals 1. And let's print out a little something to let us know, you know, which prime number we're currently calculating. All right, and then we want to say print get, oh, I'm sorry, next prime, or get nth prime, right? Get nth prime. And we want to just pass in n, and we'll go ahead and print our object again. Okay, so this should get the first prime, and then we can just copy and paste this for different values and see what we get. So this is n 10, and then do something like n of 1,000. Okay, so it calculated those very, very quickly. These were instant, right? It was, well, not exactly instant, but there was only one check because we already know we have the first prime, so we can just access it from memory. So there were no calculations necessary. Same for n equals 10. We already had that prime number. And then for n equals 1,000, we did have to do some calculations, but it wasn't that many. The computer's very fast, so it was almost instant. All right. So let's take a look and see how far up we can go. Let's do something like 10,000. Yeah, we'll just do this. So we're going to go from 10 to 10,000 right away. And notice it's going to pause here on this calculation because as this number grows, as our number of primes grows, the number of calculations we have to do on each step of this for loop increases dramatically, right? Well, it increases by 1 as our prime list grows. So every single time I go through this loop, I have to iterate through this primes list, which is growing. So each time I add an item, then this becomes longer, and there's one more loop to go through. So we have to keep doing that over and over and over, right? So this is going to require a lot of calculation because we're getting into 10,000. So one time through the loop, we will have to go through several prime numbers, all the prime numbers between 2 and or 1 and 10,000, right? So we'll see a little pause here, but then because we cached the values, when we see this one, we're accessing the exact same value, it'll be instant. Okay, so we can run this. So we're stopping on 10,000 for a minute, and then we completed, and this is the 10,000th prime number, and then we instantly got the second one because it was already stored in memory. All right, so it pauses and then executes the second one instantly. And we could go on, we could do something like 20,000 or something, and we could see that the first one, it pauses a little bit, prints the second one instantly, and then starts calculating on to the 20,000th, right? And this is going to take more time. And there, that is the 20,000th prime number. All right, so I'm gonna get rid of those. I'll comment that out for now anyway. And let's try to iterate through this thing. How can we make this an iterator? So the whole point of this is to simulate using next and sort of the iter method. Well, one way is we can make this class itself an iterator. So remember, an iterator is just a way to start at the beginning of a collection and one item at a time get to the end, or always progress if it's an infinite series. In this case, it's an infinite series. So we need to start at the beginning, and so we can have something here in our init function. We can say self.count. I guess this would be self.index. If I can spell here. Index. So the index that we're at is starting at 0. Okay, so if this is an iterator, this next dunder, I can call next, and it's going to give me the next prime number. So how does that work? Well, I can say the prime number I want is PrimeProducer dot primes self dot index. So that's the prime I want, but then I have to remember to increment my counter, self dot index. Increment that by 1, and then we return our prime number. All right, so let's try this a little bit. Let's say we want to print okay, so this should give us the first 6 prime numbers. And we'll add a little divider here too. call this iterate. Okay. Now these are all stored in memory because we already went to 1,000. You know, we can comment this out too. We don't really need to waste all that time calculating this stuff. So we can iterate. Another way we can iterate is if we actually want to kind of see these accumulate, we can add, let's see, we'll import time. And this is an infinite series, right? So we could just continue with, you know, for excuse me, for prime in our PrimeProducer instance, right? And so this should be iterable. It's iterable because we have this next property, right? So let's see if we can do this. Okay, so it's complaining because the iter function was called on this object, which the for loop does every time. Whatever it gets here, it checks with this object and says, hey, do you have the dunder iter defined? And if you do, that means it should give me an iterable. And I need that iterable because that's what the for loop is supposed to do. It's supposed to iterate over that, where p is the first value of the iterable, and then it's the second, and then it's the third. Okay, so if I want to use this sort of style of syntax, I have to make sure I have the dunder iter defined. So up here, I have it defined, but it's not returning anything. So what do I want the iter to return? In this case, it's very simple. I'm just going to return this thing itself. Okay, this is an iterator because it's keeping track of the index, and anytime I call next, it's incrementing it. Okay, so I'm just going to return self, and that should fix our problem with the for loop. So we're going to iterate over this. So the for loop always by default calls that iter method on the object. Okay, and list index out of range. So we see it did go through all of our values, and the only reason it stopped was because the list value was out of range. Okay, so how do we fix that? Well, here is the problem. What we really want is to get the nth prime instead of accessing this directly. This is going to give us the prime number in the list, and then we're going to add to the index, and then we're going to try to get the next value in the list, but it's going to be that value is going to be too big. So instead of this, if we call get nth prime, it's going to automatically call next prime to make sure we have enough values in our list, right? So that's what we probably need here for next. So we can say self dot get next prime, and what prime do we want to get? The one at self dot index. Then we increment 1 and return the prime. Now let's go back down to the bottom, and we started printing those values off very quickly. Let's slow that down a little bit. We've got this time library we just imported, and we'll say time.sleep, and we'll print 1 off every 1/10 of a second. Okay, and this is an infinite series, so that way we can kind of see what's happening, and when the numbers get too big to read, we can just stop. Get next, or get nth prime. What did I do there? Yeah, get nth prime. So again, the next iterator is going to get the nth prime. This is going to make sure that prime exists because it's got a while loop where it calculates the next one if needed, and then we get the prime and return it. So let's try this one more time. There we go. So now you see it's generating all these primes, and it would just keep doing this indefinitely because we have an infinite series. Right, so time.sleep. All the while this is going in the background. If I wanted to do something to check to see if I wanted this loop to only run for like 4 seconds or something, I could say my starting time is time.time, and I could say if time.time is less than start plus 4 seconds, then we'll break out of the loop. All right, so this is going to generate primes for 4 seconds. Let's speed them up a little bit. We'll say that the sleep time is 0.05. Let's see. Start is time.time. If time.time is if it's greater than, yeah. You gotta watch your less than or greater than. It's a common mistake. So the start time is gonna be lower than time.time here because this occurs before this one is called. Right? So this number is always gonna be lower. So the lower number, but then we add some to it. As soon as this one becomes larger, then we break. So the start time should be lower, but because we're adding something to it, this is the amount of time that we want this loop to run for. Right? We can do it like this. All right, and so that's the number of primes you get running 4 seconds when there's a little bit of a delay. So we could bring this on down to something like that too, and it's still going to run for 4 seconds. It's just going to generate them faster because there's less of a delay, and that was 4 seconds worth of prime generation, right? You can do it even more. But this way you can actually see the primes being generated. If you don't have that sleep in there, the numbers get big really, really quick. All right, so that's about all we have for this. But you get the idea of these Dunders. A lot of times they're synonymous with the global functions. So the length function checks the object and says, do you have a length Dunder? If so, I'm going to call that and get the length. Same with the string method, same with next, and same with iter. Okay, so this is sort of one way you could make an iterable. So hopefully that gives you some insights on classes and Dunders and iteration. All right, that's it for this one. Thanks for watching.